Hey guys, welcome to another video. So today we continue on with the topic of financial maths, where in the last video we explored the area relating to superannuation and investments building up over time. Today we're going to do loans and loan repayments, which is a majority of the questions actually fall into loans, right? And it's normally, anywhere between a 4 to 7 marker question in the Year 12 trials and the HSC. So quite a chunky bit of the advanced syllabus falls under loan payments. So very important for you to do it. I guess what I want to also show you today is the way that I think about loans, right? And, in terms of the formula, there's a set way that the textbooks and the past papers do it. I thought I'd give you guys a diagrammatical depiction of what the formula is trying to say. But before I go on, if you haven't already done so, please subscribe to the channel. Give me a like on the video. It just helps with people searching for the video. All right, so guys, let's dive right in. So I'm going to zoom in there. Loans. Yeah, more specifically, loans and loan payments. Yeah? So, the diagram here is that that I always like to draw for my class is we have like n equals 0. At time 0, what happens? You borrow a loan, right? So this loan amount here is, it might be $100,000. Let's say that's L. Okay, and let's let the AN represent the amount that you owe after n months. So at the beginning of time, if you borrowed L dollars, you'll owe L, right? Cool. Now, so what happens over the passage of time? So when n equals 1, after the first month or the first year, let's talk years for now, right? Simplify. After the first year, what happens? We know that the loan gets charged with a little bit of interest, right? So the bank charges you an interest rate and that interest built on that. So your loan payments goes from the blue to the blue plus the red. But then what actually happens thereafter is that you cut it down with a loan repayment, right? I'll use the M because normally it's months and it's a monthly repayment. But what happens is the blue increases with the red with interest, but then it gets cut down by amount representing the periodic repayment, right? So then the amount that you owe at the end of the period, right, is A1. Yeah, so A1, actually, maybe I'll write it in the box itself. A1 represents the total amount at the end. Now, so without going into the formulas, what happens, month on month, period on period, n equals to 2 is exactly that. That's the closing amount at the end of the first period. You then get charged a little bit of interest for the next month, and then you cut it down again with a monthly repayment. So you can imagine that, after a series of months and periods, right, you have a picture, ... that eventually, right, that loan repayment is quite tiny, right? So maybe I'll do it just before here. It's quite tiny. Let's say this is the period of, this is a n-1 or capital N-1. So the second last, sorry, I can't write, n-1, which reflects the second last period before your whole loan's paid off, right? So what happens on the very last period, right? In the very last period when n equals to capital N, right? And let's say capital N, let's say if this was a 30-year loan, capital N will be the last payment. So that if it's an annual payment, it's the 30th year, or if it's monthly payment, the 360th period. You get a slither of interest that gets charged on that. But then more importantly, the last repayment that you do wipes off your whole loan, right? So that the A capital N is 0. So you can sort of see the progression, right? You go a bit of interest, cut it down, bit of interest, cut it down, bit of interest, cut it down, and then finally you pay it all off. Now, this diagrammatical depiction of the maths is what you need to then now prove with algebra. And just to be absolutely clear, whenever you prove this, and if it doesn't say so, you need to prove the pattern up until n equals 3. Right? That's always what the teachers tell you to do in the test generally. And then you basically can infer the pattern from that using GP. So maybe I'll say this is the first part I of the theory, then part 2I, just to be clear about the key formula we're going to use. The sum of a GP is A 1 minus R to the power of N over 1 minus R. Yeah, that's the key formula we're going to utilize in this topic. So putting those two together, let's do a question. So what I want to do today, I'll give you a simplified example, and then I'll show you an example from a past paper question. Right? So let's put these together. Let's do a question, quite simplistically. So I know Carl, it's a great name, borrowed, let's say $500,000, so $500,000 from a bank where annual repayments of $M are made at the end of each year. The interest charged is, let's go simplistic, maybe 6%. So it's always a good one. 6% per annum. Yeah. Let AN equal to the loan balance after N years. Now, keep in mind, this is slightly detached from reality, where in reality, most of the times when you borrow a loan from the bank, it's monthly repayments. This is an annual repayment, but the concept's the same, right? Concept's the same. All right, part A. Show that AN equals to 500,000, 1.06 power of N minus M 0 N minus 1 N 6. Yeah. B. Find the value of M. Now, the beauty of this question is that using the theory that you use here, you can actually do a very similar calculation in real life when you go or your parents go to borrow money from a bank. This is actually the formula, or something similar to this, is the formula they use to calculate the monthly repayments that you have to make, right? So let's do this. So we have in this question, so let me just highlight the key aspects, right? We're borrowing 500,000, right? That is the loan amount, right? That's loan amount. We have interest rate, right? That is R. Yeah, and we have, well, monthly repayment, right? Yep, so cool. And AN is the loan repayment after N years. Perfect. Okay, let's do this. So remember, in the diagram that I had before, time 0, so we always start with A0 equal to the loan amount, which is 500,000, right? And then over the passage of time, what happens? We have an interest amount that's charged to this compound interest, and then it's offset by a monthly repayment. So I'm going to use a little bit of colors, right? So maybe I'll access my colors here just to really give you that flavor of what's happening here. So at time 1, what happens is it's always time 0, right? Multiplied by 1 plus R and then minus M, right? That's the formula. Yeah, that's the formula at play. So what that means is that A0 is 500,000, 1 plus R is 1.06, and then minus, now M is still missing, so I'm going to leave it there. All right. So we have proved, we start with A0, we proved A1, right? Let's keep going. Remember, the question here, if I'm asked to show, your teacher would assume that you would go to prove A3, right? A3, and then you can infer the pattern. So you know what, my spatial I'm just gonna move this to the next page because I want to show you this all on the same sort of column. So now, so once I do that, I'll reset passage of time. We're now at n equals to 2. A2, I know starts with A1, 1 period of compounding again, minus a monthly or annual payment in this case to cut it down, right? So once again, I do exactly the same thing. I'm going to do actually 3 things here, right? First thing I'm going to do, this guy gets plugged in to this guy, and then the interest and then the monthly repayment, which is empty, right? So 500,000. It's a really simple math here, but just be, you know, it's the method and the process that is important, right? 1 plus 1.06 minus m. Now, using rainbows, just expanding this, right? So then you get 500,000 times 2 lots of this, and minus m 1.06 minus m, right? And just be absolutely clear in terms of the colors, right? Here is 2 lots of interest, which represents 2 buckets of 2 rectangles of that interest. And then you can sort of see there's 2 lots of monthly repayments, which cut it down. The reason why one is just m and the other one's just 1.06 is because they're made at different points, right? And you'll see over time, the m's form a GP and the 500 times 1.06 is just compound interest, right? So guys, that's A2, perfect. Right, let's now develop A3, right? And then once we develop A3, we can then infer the pattern. So what's A3 again? Always start with A2, compound 1 period of interest, right? 1 period of interest, oops, put the formula in, and then minus m again. And guys, just like I did before, this whole expression here, right, becomes my A2, which I will then plug into here to get square brackets 500,000 1.06 power 2 minus that, that's m 1.06 minus m, and then once again some rainbows. Yeah, you can sort of see what's going on here, right? So then I get 500,000 times 3 lots of these guys, power 3, and then that guy powers up by 2. That guy's got 1. That guy's got m. And once again, there is my interest repayments, my interest building up over time. And there are 3 lots of m payments which cut down my loan, made at different points. So that's why there's different numbers. So now I get the pattern, right? The pattern is very simple, right? And this is why I like to show you in green and pink, because the pattern basically suggests there's an element over here, right, that grows over time. So, and then there's an element over here, right, that has interest allocated to it. So let me see if I can find a pink. Yes, beautiful. Right. Sorry, it's a bit OCD. So I use red upstairs. Maybe I should use red over here. There you go. That's better. Now, so what that means is if I sort of say, okay, ... I can infer a pattern. The pattern has 2 elements. On the red box, you can sort of see, guys, when n equals to 3, this power is 3. So when that's n, I can say that's 500,000, 1.06 power of n, right? Perfect. Now, on this green box, it's a bit different. When that's 3, I know that there's 1, 2, 3 terms, right? 3 terms, but also the highest power is always 1 less, right? So what that means is if I infer the pattern, I'll go minus m 1.06, 1 less than n is n minus 1, minus m 1.06, n minus 2, and then minus ... And the smallest one would be 1.06 and minus m, right? So guys, just to be absolutely clear, that guy there is pink and that guy there is the green payments, right? Now we're talking, because now the mass comes in, and the whole reason why series and sequences is related to this is that green part forms a GP, right? So before we do that, actually, let's clean it up for our GP formula to kick in, right? So if I minus m, you know what? I'll reverse the order of this so that the smallest one comes first. So that's a So factorizing minus m from the last term, that's 1. Factorizing that, I get 1.06. And you can sort of see the pattern sort of, factorizing m from that, I get 1.06 power of n minus 2. And then that one there, 1.06 n minus 1. Beautiful. Yeah. So, I don't have any more vertical space. Not good. Can I move this over here? Because I really need it to sort of all flow nicely, right? So that is a GP, right? That is a GP. Yeah, because it's got a common ratio of 1.06, right? So just to be clear, if it's a GP, identify A, which is 1, R, which is 1.06, and N. Now, it's just like last lesson, and N minus 1's the highest term, but it starts with 1, so therefore N is N, right? So then sum of a GP there, if I just said equals to 500,000, yeah. And I think I wrote the sum of a GP formula on the previous slide. I'm using the wrong one, so I'm using the one with the reverse order. I'll show you what I mean by that. So guys, this one here, it's A times 1.0 n minus 1 over 1.0 minus 1. In the previous slide, I did the 1 minus R1, right? But it's the equivalent, right? This one's R, yeah, same thing. So just to be clear, that there is the GP for that, which then, cleaning everything up on the bottom, especially because 1.06 minus that is 0.06. That's exactly what the question wants me to show. Therefore, AN equals to 500,000, 1.06 power of n minus. Now the 1 goes away, right? So then you got m outside of 1.06 power of n minus 1, 0.06. Yep. And we put a box around it, but I'm pretty sure that's what the question wants me to do. Let me just highlight it. Let's have a flick back, have a look, right? Yep, there it is, right? Show that. Now, once you do that, what isn't clear in the question, and sorry for omitting it from the actual question itself, find the value of m if, let me get rid of this. I didn't actually tell you how long this loan goes for, right? If the loan, let's say 30 years, no. If the loan is fully repaid after 30 years. Sorry, should sort of stop that, didn't I? Is it a 30-year loan? No, 20 years. Yeah, in my notes here, I've got 20 years. Let's do that so it's consistent. Yep. Now, what's I mean by 20 years? So going back to the diagram here, after 20 years, right? If n was 20, the loan's fully paid off. A20 is 0. That's super key, right? So if I go over here, go to a new slide to do part B, right? This is saying, what I'm going to do, guys, I'm just going to copy this formula that I proved because I'm going to actually use it over here, right? All right. So what we're saying here is that if this is a formula for AN, I know that after 20 years, the whole loan is paid off, right? This is crucial because what I'm going to do now is every time I see N in the formula, I'm going to sub in 20, right? I'm going to sub in N equals to 20. And then I know then that would equal to 0. And then I'm just going to make M the subject, right? I'm just going to make M the subject. It is that easy. So let's do this, right? So I go A20 equals to 500K times 1.06 power 20 minus M 1.06 power 20 minus 1.06 equals 0. And then it's a case of making M the subject, right? So throw maybe this whole bracket thing over the fence. So you got 500,000, 1.06 power 20, M 0.06, 20 minus 1, 0.06, right? And then, I want this guy, I want these guys over, so times a 0.06 up, divide that guy down, make it the subject, therefore. M, it's 500,000 times 1.06 power 20 times another 0.06 all over 0.06, 20 minus 1, right? So this was a cooking show. We would have done this in an oven separately and go, therefore, the answer for M would be 592. Always try to give it to the nearest cent, right? Yeah, or nearest dollar, whatever the question says. If it doesn't say nearest cent, be good. So that's how you do it. So structurally, it is really important for you to identify that we prove the pattern down to A3. We infer the pattern for the red bit and the green bit. It's the green bit that has a GP. Put in the GP formula, get the formula, right? And once we have the formula, most questions would at least have the next part being find the value of M, right? Now, some other questions, and I'll touch on this next lesson, or maybe the lesson after, actually. Next lesson, we're going to do annuities. The lesson after, where there are harder examples of this, right? Where they basically try to change the textbook nature of this to either give a further element in the end, like say, for example, they might change the interest rate during the period, or add a few more elements where they can either try to repay faster, et cetera, et cetera. So we'll touch on that later. But for now, let's do another textbook past paper question, right? I believe I got one from Sydney Boys, 2012. This is very textbook, right? Yeah, this is like similar to the one we did before. Let's have a look. Mr. B borrows P, right? This is interesting. So it's textbook, but it reverses the things that they gave us, right? Because instead of us not knowing the monthly repayment, in this case, we do not know the value of the loan, right? So for his new Nissan supercar. Great. It's a very all boys school question. And the term of the loan is 10 years, right? Let's highlight that. 10 years, interest rate of 6%, monthly reducible, right? So it is a monthly question. He repays the loan in equal installments of 750. Great. So in this case, you can see, right? Now, even though this is 10 years, we need it in months. So N would be 10 times 12, which is 120. We know that the interest rate is 6% per annum. Yeah, but I want monthly, so divide by 12, so 0.005. And then the monthly installments, right? M is 750. Yeah. Now show that. You can sort of see it structurally. It looks, end of N months, it looks very similar to what we did before, slightly different though, and I'll show you why. So just be clear, there's the interest rate part, right? There's the interest, and there's a green part that is supposed to be a GP. I suspect that for this question, if you use the GP formula, expand it a little, you'll get exactly what you do there. Now, let's see what's part 2. If at the end of 10 years, the loan has been fully repaid, calculate the amount. Okay, cool. 10 years fully repaid, right? That's it. That's key. Yeah. So find P. In other words, calculate the amount. Find P. Yeah. 5 marks. You can see there, right? It's 5% of the whole test for loan payments. So let's see. Show. So N equals 1, 2, 3. So 0, 1, 2, 3. So after 3, we can then infer an expression for N, right? Cool. So in this case, let's see. Now they don't have the subscript here, but you and I, let's introduce it. A0 is P, right? That's how much we owe at the start. Then A1 will be P. Remember, yeah, let me stick with the colors 1 plus R and minus M. So in this case, it'll be A1 will be P 1.005 minus 750, right, in this question. Yeah, tick. A2. I got A1, once again, a little bit of compound interest, cutting it down with a monthly repayment. So that, then remember, I'm going to sub this into here, which gives me square brackets P 0.005 minus 750 square bracket. Zoom in a bit more, so I write a bit neater. 1.005 minus 750. Guys, expand that using rainbows. Therefore, A1, A2 rather, is P 1.005 squared 750, 0.05 minus 750. Once again, there it is, right? The development has two parts. You got the compound, which is red, and then the monthly repayments, which is green, right? Perfect. Now, how much vertical space? Yes, I can fit in. I reckon just delete this date. I reckon we can fit in A3. So let's say A2, compound interest that. Cut it down with monthly repayment. Then same as before, that guy goes into here. Yeah, nothing about this question is super hard or super involved. It's just a bit tedious just writing this all out. Yeah, but if the question itself is just tedious, then it's pretty sweet. Guys, rainbows that, and you get P 1.0053 minus 0.005 minus 750. All squared there, 1.005 minus 750. So here lies the pattern, right? So just be clear, there's a compounding part, and there is the monthly repayment. So then we can infer the pattern for N. Now I don't have more space. I'll do it over here. I can say, therefore, A, right? Now they use A. Normally we will put AN, but they use A. So I'll just put A equals to P 1.005. Now, just remember, right, that when this is A3, by the way. Yeah, when N equals to 3, the pink part or the red part, right, has power of 3, so same power. So what that means is, if this is, technically, you know what, I'm just going to put an N here just so I can refer to it, right? If that's N, then this should be N as well. And for the green, right, the highest power is 1 less, and there are the same number of terms, right, as the red 3. So if there's N here, it will be minus 750, 1.005 to the power of N minus 1, minus 750. Now, I'm not going to be lazy with my working out. I'll just write everything out for you. And minus 750, 1.005. I can't fit that, so I'm just going to move it over a bit. Minus 750. Yep. Now we do our series and sequences, right? So firstly, before we do that, that's the green, that's the pink, and we will factorize the green out, right? So now let me just get rid of this N again, because the question doesn't have it, right? So let's just be accurate. 0.005 power of N minus, now looks like I factorize 750 out. Gives me a, reverse the order again. So you get your nice GP being 1.005 plus 1.005 power of N minus 2, 0.005 N minus 1. And that is our GP. So let's identify that as such, where A is 1, R is 1.005, and there are N terms. Sum of a GP to that, please. Then you get 1.0 P times 1.005 power of N for the red part. That hasn't changed. Minus 750 now. Use green to denote this GP. So A times 1.0 R to the power of N minus 1 over 0.005. No, 1 R minus 1. Yeah, perfect. Is that all right? So now, right now, you're probably thinking, if you clean this up, right? If you clean this up, just to be clear, the 1 goes away, and this guy goes to 0.05. You're probably thinking, well, therefore, AN, or A in this case, equals to P 1.005 N minus 750. You're probably thinking, well, that looks a little bit different. Why does it look different to what they want, right? So let's see what they want, right? Let me just quickly go over here. If you look at it, Now the pink part looks exactly the same as what they want. Yeah, that's great. But the green part looks a bit different. Why? Guys, two things. Can you see where they got, see how they have like 150,000 on both terms? Where did they get that from? If you take this guy, divide by this guy, yeah, I think it's like 750, divide by that guy's like times by 200. You will get this guy and this guy, you will get that, which is exactly what they want. And how did they get two terms? They then expanded the rainbow. Yeah, so they actually introduced one more step, which case we will do that as well. Just move this up here. Yeah, to basically get the step. So 750 divided by 0.05 is like times by 200, so you get that, and then you expand it. So I'm just gonna, let's just do it, right? A equals, now which one did they? Oh, I'm just gonna, let's just copy and paste the thing I need to prove, because I'm sure if you're at this point in a test, your teachers will accept that you have done exactly that. So minus 150 times 1.005 power of n, that's the first rainbow. And then the second one is that times 1 becomes a plus because it's minus times minus. That's my answer. Is that all right? That's 3 marks in a Sydney Boys past paper, but you can find this question so often. There's always one series financial maths question in, at least one in most Year 12 trials and HSC. So just make sure you do it. Now find P. I think I can actually do it on the same page. Maybe I'll be ambitious and try to do so. Because all I got to do feels like for part B, or part 2 rather, yeah, at A10 to 120, right? The loan is fully paid off, and that is crucial, right? As a fact. So what I'm going to do, let's sub 120 to all the values, right? 120 to all the values of n up here, and this should give me 0. Yep. So let's do that and make P the, so what am I doing? I'm making P the subject, right? That's what they want me to do. So let's do that now. So P 1005 and 120 minus 150,000 1.005 20 plus 150,000 there. That gives me 0 because the loan's fully repaid. So let's make this guy the subject, chuck these two over and divide by 1.0005. I think you get therefore P equals to this, that. Yep. And if you punch it now, there's nearest dollar, perfect, even better. Therefore, P, if you did it correctly, should be about 67555. Guys, 5 marks, Sydney Boys. How's that? So hopefully that gives you some sort of framework for doing these loan questions, right? So we always start with a 0, 1, 2, 3, infer an, and then if they give you an end date, use that as 0, and then sub in the value in and make whatever you want the subject. In the first question I made the monthly repayment, in this one I made the loan amount. Guys, hopefully that was a useful video. If you haven't already done so, please like the video, tell your friends, and I will see you in the next one. Thank you. See you guys later.